Okay, this is 4.2a, more about parallelograms. Okay, quadrilaterals having certain characteristics must be parallelograms. So they have to have certain characteristics. So let's talk about those characteristics. So if two sides of a quadrilateral are both congruent and parallel, then the quadrilateral is a parallelogram. We also know if both pairs of opposite sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Lastly, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So those are our three characteristics that take a quadrilateral to make them a parallelogram. We have to have two sides that are both congruent and parallel. We have to have opposite sides of a quadrilateral are congruent. And then the diagonals bisect each other. So any of these will force a quadrilateral to become a parallelogram. So this is a little bit different. We're kind of jumping back into triangles for a minute. But the segment that joins the midpoints of two sides of a triangle is parallel to the third side and has a length equal to half of the length of the third side. So as you can see here, DE, or rather D, cuts AB into two congruent pieces, and E cuts BC into two congruent pieces. This does not mean that DB and BE are congruent. These can be separate lengths. So we know that DE is parallel to AC, and we know that D and E are the midpoints, so DE connects it. So that tells me, we know automatically, that DE is parallel to AC. We also know that the length of DE is equal to half the length of AC, which can also say that AC is twice the length of DE.